All right, let's get this. All right. So we are going to do, we've done these problems before and we've used the calculator. Now I'm going to show you guys how to do these without doing like second calculate intersect, right? This is the way I'm more familiar with doing these. So we want to know, when will our balance double? Sound good? So if our balance doubles and we start at 1,000, what's double of 1,000? 2,000 equals 1,000 e to the 0.065 t, right? Any questions what I did there? Do you want to know a secret? A deep, dark secret? No. Anytime you have a doubling problem, could I just put 1 here and 2 over here? Yeah. Because the time it'll take $1 to double is the same amount of time it'll take $1,000 to double. Does that make sense? So if you ever see a doubling problem, you can always do 1 and 2. If you ever see a halving problem, you can always plug in 1 and a half or 2 and 1. Does that make sense? It always works that way. Because what's going to be my first step to solve this equation? Divide by 1,000. And what happens when I divide by 1,000? I get, oh. So no matter what, if it's tripling, it's going to be 3. If it's quadrupling, it's 4. Nantupling.
Is that just getting rid of a step?
It's getting rid of a step. Thanks. That's the one smart thing I did today. All right. How do I get rid of an e now? So I'm a natural log both sides. So I get natural log of 2 equals 0.065 t. Do you see what I'm saying? So I know I've told you guys to use, these problems do not take long, you know what I mean, compared to graphing. A lot of times these are actually quicker just to solve out like this than graphing. Does that make sense? Where were you for the picture? Mm-hmm. Mm-hmm. All right. Now what do I do to both sides? Just divide by that, right? Do you guys want to know another crazy secret?
That's your answer.
If you do a lot of doubling problems, it's always natural log of 2 over whatever that is. Every time. In fact, that was shown earlier, like showing the rate of doubling time. A long time ago, it's in your notes. But that's where the formula comes from. What does that equal? T equals 10.664. 10.664 what? Hot dogs? Years. Y'all, if you ever find something that you can double your money in 10 years, put every dime you have in it. I concur. This would be an equals, right? I agree. Exact, approximate. Thank you.
Have $1,000 to double. Put more money in like 2 months. Would double fast.
You'd get to 2,000 faster, but won't double per se.
2,000.
What? All right, so that's A. How can I find the inverse?
That's your answer.
So my original equation is A of t equals 1,000 e to the 0.065 t, right? Do y'all agree on that? Do you want to write this in terms of x and y? Is that beneficial, or can I leave it as t? And I can use a and t, right? So I can say then t equals 1,000 e to the 0.065 a amount, right? All right, let's do it. What do I do first? Divide by 1,000. My cursive. I tried to invent cursive numbers when I was a kid. It didn't catch on though. Instead, I got a job where people just curse at numbers. So I have t over 1,000 equals e to the 0.065 a, right? How do I get rid of an E? Natural log it. So I get natural log of t over 1,000 equals 0.065a. And oh, why would you do that? Divide by 0.065. What? So this is now my,
Exact.
that's my exact, but that's my formula for inverse. That's my inverse, right? So I would say A inverse of t equals this piece, right? Well, I don't know if I would have wrote that. What does this even tell us? What does this give us? What's the inverse give us? Do you want to leave? Let's leave it. Let's leave it like these letters. What does this tell us? Yes. It's the opposite. Oops. Spell, good. Because this gave us our amount in terms of time, right? This gives us time in terms of the amount. So if I give you the amount of money I want to make, it'll give me out how much time I need. So if I want to make $5,000, I plug in there and see how long it'll take me to get $5,000. So amount given time, time given amount, right? All right, let's graph it. By the way, my YouTubers, go Michigan, go Blue. If they win tonight, y'all can come here for a free pirate ticket. Don't come here. They're fine, I guess. They exist. All right, so let's graph the inverse. All right, that's my inverse. Which equation is the inverse? The arrow, right? How do I know it starts at 1,000? Because at 0 time, how many monies should I have? 1,000. How long does it take to get to $1,500 according to this? Actually, 6.24 actually. I don't know why I put that on there. Oh, never mind, because it was this question. So what does it mean at 1,500, what's my time? Yeah. So what's that? If I had to write this as a sentence, what would I write? I'm going to write up here so y'all can see it better, but put it down there.
6.25.
Yep. I don't think it'll matter. Don't quote me on this. But I'm plugging 1,500 and then getting an answer. So I'm going to start with the 1,500. Does that make sense? I'm starting with 1,500. So the balance will be $1,500 after. This is for D. I just didn't want to write it low. 6.25 years. Why don't books make realistic like accounts? No, but you're not doubling your money or making 500. Actually,
What if I have $1?
if you invest in mutual funds, average return is 10%. You would actually make more than $1,500 if you invest in ETFs.
Yes.
ETFs. They're a bunch of stocks combined into one. So like you're buying like 400 stocks at once. It's a low risk investment. So you don't make as much, but it's pretty close to guaranteed money. If you sit on, you have to sit on it for 5 years. That's the rule of thumb. 5 years.
Is it like a CD like sitting on?
No, those are different. But so, just now, if you like to learn more, read a book or something. I don't know. They got books at the library on this actually. Just short stocks. That's all you do. All right. Are we good on this one? Are we okay on it? That's a good free response question you might see. No, they don't actually. Some schools do. They use their fund balance to invest. Actually, major universities use their fund balance and they invest it, and then they use the capital from their investments to use improvements, and then they don't touch their fund balance. Because some have, I don't know. I listened to a podcast called Revisionist History that did a full year on it. All right, let's do this. Complete the table, and let's find the solution. Sound good? Yeah. Why would you ever do it this way? I don't know. Let's do it. So what we're going to do is, let's say, this is a way to solve equations that you don't know how to do. How about that? Do we know how to do this problem? I can natural log both sides, right? Divide by 2. Answer. What if I don't know how to do that? What if I forget how to graph it on the day of the test? This is going to be another way that we can solve an equation. So if you don't like this way, I don't think you'll ever have to use it, but I'll give you an idea. So I want to solve this, and all I remembered how to do is plug in numbers in my calculator. That's all I know how to do. And it's not multiple choice. Did you guys know that there's a way you can cheat the system by cheating the system? So now they start with these intervals. Let's say you plug in 1, 2, 3, and 4, right? By plugging in those big numbers, you'll be able to narrow down where the solution will be, right? When you plug in 1, it's not 60. It's way too small. When you plug in 4, it's way too big. When you plugged in 2, it was actually pretty close. And when you plugged in 3, it was too big. So you know the answer is between 2 and 3, right? So now they said they got between 1.8 and 2.2 magically. So what I did is I plugged in 1.8 into that, and I got an answer. I plugged in 1.9 and got an answer. I plugged in 2. Now again, I would have, in real life, would I have done these ones? No, I would have plugged in 2 and 3. And I noticed when I plug in 2, look at that. That's really close to 60, isn't it? Now, if you're doing that second enter trick, do you guys remember when I showed you that? It doesn't take long to plug these in, right? Now, again, would I do it this way? No, I'm going to solve it or I'm going to graph. But this is a way to cheat equations a little bit. When I plug in 2.1, I get 66.69. So now, right there, I would stop. Would I plug in 2.2? No, because I know it's between those two answers, right? Now, could you, which one's it closer to, 2.0 or 2.1? 2.0, right? Now, we could do multiple things with that. We could take it, graph it, and then use our graphing equality, and then we know it's between those two solutions, right? Or that'll help. This can also help you guys. Maybe you're bad at finding your windows, right? Maybe you can graph it, but you're bad at finding your windows. You can plug them in and see where it is, okay? But I don't want to do a whole, that will give you a hint, right? Now, please, if you're good at second calculate, or you plug this in, plug that in, second calculate, intersect, just do that, right? Just do that. If you're good at natural log, divide by 2, like, right? Could I just do that? You get 2x equals natural log of 60. X equals natural log of 6. Like, how long did that take? Not long. But I just want to tell you, it's okay if you get really stuck on a problem, start plugging numbers into it and see what's happening. Get an idea of what's happening. All right? On B, could I plug in numbers, get an idea where it is? Well, what should we do, though, on it? Divide by 2. How do you get rid of that log? Yeah, you take both as a power of 3, right? And so those cancel. I get 0.5x equals, what's 3 to the third? 27. Oh, not 3 to the third. What's 3 halves to the third? 27 over 8, right? 27 over 8, because you cube both. No, you dingus, Mr. Twilliger. What is 3 to the 3 halves? I'm sorry.
6. About. No, I go back and 12.
Help me out. What's 3 to the 3? It's not 12. It's like 5.1, I would guess. 5.19? So 0.5x equals 5.19. And then you divide by 0.5. I tried to rush it. I apologize. So I'm just alerting you that you can take advantage of technology. I'm not a huge fan of it, but it's okay when you're stuck. Hi. Me? That's it for the day, though. That's all I got. Go Blue.